Landing and approximately up can have some difficulties. Obviously, your goal is to slow down your descent enough that your landing feet can absorb the blow. This is sometimes easier said than done if you're not overly familiar with the thrust-to-mass ratio of your ship, or you panic burn when falling too fast, and all of a sudden you find yourself acting more like a pogo stick than a sophisticated aircraft. And so we naturally find ourselves asking the question, if we have all this fancy logic and electronics available to us, can't we just make something that handles the landing for us? And that question is what brings us here today. The way that we humans manage descent is by watching the speedometer and increasing thrust proportionally to it. However, the problem with speed is that it doesn't tell us what direction we're moving, and we don't want our machine touching the thrusters unless we're strictly falling. What we can do instead is remove the speedometer and plug our input from the altimeter into a differentiator. That's the box with the Greek letter delta on its face. This calculates the rate of change in our altitude, effectively matching what our speedometer offered us, but with one difference. The output is now negative when we are falling. This is what science nerds called velocity, speed with direction. Side note, adjusting the knob on the differentiator adjusts how frequently it updates. For our purposes, we'll want something that updates as often as possible, so keep it at the 1/60 setting. I'm going to move this logic behind our bench for more space. That wireless signal tuned to 2 runs back to our display from before. Now, when we fall, our velocity is a negative number, but we want that to correspond to a positive thrust, so we'll need to multiply this value by a negative number. This constant relates how responsive we want the lander to be. Usually I find values between -1 and -2 work fine for ships that are, well, more than just a cockpit. You'll see later that what I've got is a little too aggressive for how small of a test vehicle I'm using. The last thing we need to do is run our system into a switch, allowing us to disable our manual controls, turning on the automatic landers. You can see in our test flight that after a short takeoff, we switch on the auto landing. Thrust cuts out, and once we begin to fall, it keeps our downward velocity at an incredibly small 0.03. Note that our constant piece from earlier should be adjusted to a smaller magnitude in order to land faster. You can also replace that constant with the output of a lever. Just make sure to remap its output to a range going negative. This lets you manage the descent while removing the ability of accidental takeoff. My last showcase here is the system put in place on my own lander I used for the lunar missions. As you can see, a heavier constant like 1.7 works great with a craft as heavy as this. Another benefit of a system like this means I can put all my focus on horizontal alignment using my downward cam and side-to-side thrusting. No need to worry about how fast I'm falling. It's just already handled. Anyways, that's about it. It's a rather simple system here, not a whole lot going on. If you guys liked this video, I'll probably upload more once this game has a full release. Until then, thanks for watching.